This is Class 10th Science Chapter 3 Metals and Non-Metals Lecture 3rd. In this lecture you will learn number 1 reactivity series, number 2 reaction of metals with non-metals, and number 3 ionic compounds and their properties. First I tell you what is reactivity series. Reactivity series is the list of metals written in order of their decreasing reactivity. It means in this series the metal which is most reactive lies at the top. The reactivity of a metal depends on how easily that metal loses electrons to form a cation. On being dipped in a metal salt solution, metal tends to form cations in that solution. The part of the metal out of the water therefore acquires a negative charge. Here I have taken aqueous salt solution and put a graphite electrode into it. I take second electrode as aluminium first. I connect carbon electrode with the positive terminal of the voltmeter and negative with the aluminium metal. You can see the potential developed is 0.78 volt. On making Cu or copper as cathode, the potential developed is 0.16 volt. You can see here in the voltmeter. Next, on making nickel as cathode, the potential developed is 0.27 volt. And on replacing this with the iron, the potential developed is 0.45 volt. It means different metals develop different potentials on being dipped in aqueous solution. The electrical potential developed depends on the metal and some other conditions. On dipping two different metals, the metal that acquires more negative charge is more reactive. The potential developed under standard conditions with respect to a hydrogen electrode is called standard electrode potential. We shall learn more about standard electrode potential in 11th class. First group metals have highest standard electrode potentials because they lose the electrons most easily to become cation. After that come the metals of second group. It means first group metals are most reactive, then second group metals. Next, at point number 2, we discuss the reaction of metals with non-metals. In general, metals have tendency to lose electrons, while non-metals have tendency to gain electrons to acquire noble gas configuration or a stable configuration or to complete their octet. More the difference in the tendency to acquire or lose electrons in a metal or a non-metal, more charge separation shall be caused in the compound formed by those such elements. Hence, more ionic properties would be there. It means the reaction of first group metals with the 17th group elements form most ionic compounds. First group metals have only one electron in their outermost cell. Hence, they have maximum tendency to lose electrons. And the 17th group non-metals, they have only one electron less to complete their octet. Hence, they have maximum tendency to gain electrons. Therefore, the reactions of first group metals with 17th group metals produce ionic compounds. This difference is quite large in second and 17th group. Therefore, second and 17th group elements also react with each other to form ionic compounds. You have studied that 8 electrons in the outermost cell generally give electronic stability to the atoms. We take the example of sodium. Atomic number of sodium is 11. It means it has 11 electrons and 11 protons in one atom. Electronic configuration of sodium is 2 in the first cell, then in the second cell the number of electrons is 8 and in the outermost it is just one electron present. On losing one electron in the outermost cell, it acquires noble gas configuration because now 8 electrons are left in the outermost cell. Now let us consider chlorine. Its atomic number is 17 and electronic configuration 287. Means 2 electrons in the first cell, 8 electrons in the second cell and 7 electrons in the third cell. That means it needs 1 electron to complete its octet. On reaction of sodium and chlorine, sodium loses 1 electron and chlorine gets that electron, and both of them acquire noble gas configuration, or they complete their octet. When sodium loses electron, it acquires unit positive charge. And on gain of electron, chlorine atom acquires unit negative charge. This charge difference strongly holds sodium and chlorine atoms alternatively. Therefore, ionic compounds don't have discrete molecules. NaCl is thus a formula unit and not a molecular formula. Same happens in case of group 2 metals and group 17 non-metals when they react with each other. For example, let us have a look at magnesium and chlorine reaction. The compound form is magnesium chloride, which is an ionic compound. Now I tell you the properties of ionic compounds. Number 1, they are crystalline solids and have high melting and boiling points because the ions, they have very strong electromagnetic attractions. Number 2, they are brittle. Number 3, their solubility in water is quite high because water is a polar solvent, and the ionic compounds dissolve in polar solvents and not in non-polar solvents like kerosene or petrol. Number 4, these compounds ionize in water on being dissolved. Number 5, in solid state, they don't conduct electricity because ions are strongly bound with each other. But in molten state, or when they are dissolved in a suitable solvent, they conduct electricity because the ions get separated. In the end, I summarize this lecture. First, I discuss about the reactivity series. The reactivity of metals is different. More reactive metals displace less reactive metals from their salts. The list of metals arranged in decreasing order of their reactivity is called activity or reactivity series. The reactivity is measured as standard electrode potential. Next, I discuss that metals react with non-metals to form salts. For example, metals react with oxygen to form oxides and with sulfur to form sulfides and halogens to form halides. Highly reactive metals like first and second group metals, they react with non-metals like halogens to form ionic compounds. Ionic compounds do not form discrete molecules. They have high melting and boiling points. Ionic compounds conduct electricity in molten or in solutions only and not in solid state. That's it, my third lecture of this chapter. That will be continued in lecture 4. Till then, goodbye.